Welcome back to Physics 30. This is booklet B, Electric Circuits. And in this video, we'll be looking at defining and providing examples of a series circuit, parallel circuit, resistance, conductance, superconductivity. State Ohm's law. Apply Ohm's law to problems in electricity. Use the correct units and symbols for resistance. Identify the four factors which influence the resistance of a cylindrical resistor. Express the proportionality statements for each of the factors that influence the resistance of a cylindrical resistor. Express the correct units for resistivity of a material. Solve problems relating to factors which influence the resistance of a cylinder. So there'll be two videos. The first part will deal with 1 through 5, and then you'll be able to do the quiz after that. And then the second video will deal with 6 to 9, and there'll be another quiz involving that. Okay, so first of all, what are the four basic parts of a simple circuit? So of course you need to have an energy source, which could be in the form of a battery. Conductor, something to transfer electrons throughout the circuit. And the whole point of having a circuit is to do some work on something, such as a device such as a light bulb. And lastly, a controlling device to turn the circuit on or off, a switch. So of course here this is what a switch looks like, as we've seen in the previous video. Light bulb, battery, the shorter side is the negative, the larger side is the positive. And of course current can't flow here because there's a break in the circuit. But if we're to put that switch down, close the switch, electrons can go through the circuit and light up the bulb. Now on page 37 of your duotang, there are other symbols that you could look at. Besides light bulb and switch, there's many different other ones. And there are many different ways of looking at a current itself. Classically, it was looked at as being the flow of positive fluid. But of course, as we learn more information, it was determined that it is electrons that flow. The flow of electrons from the negative to the positive pole, and not some sort of positive fluid that goes from positive to negative. Series circuits, summarize 4 points concerning series circuits. Each device is connected in a single loop or path, and electrons go from negative to positive pole, and the electrons pass through every part of that circuit. If there's a break at any part of that circuit, the electrons stop moving and it's over. We don't have electrons doing work through any devices. Parallel circuits, though, as you see here, there's alternate paths. So when an electron comes over here, has a choice, could go this way or this way. It goes through the light bulb, then they meet up over here and go back through the single loop back to the positive pole. So each device receives current independently of the other, and if there's a break in one of these parallel branches, it doesn't affect the other one. So if there was a break right here, electrons would continue to go through this one. If there's a break over here, electrons would continue to go through that light bulb. Okay, so that's the difference between series circuits, parallel circuits. And as I mentioned before, current, kind of two ways of looking at it. Classically, the old way is the flow of positive charges or positive fluid, the term that was used. Or electrons. So they're both in opposite directions. Describe electrical resistance in a conductor. Can be related to water through a pipe. So through some resistor, etc. If you have a water pipe, and if there are scales on the inside of the pipe, deposits of calcium, etc., it causes large resistance because the water has to really work to get through the pipe. Resistor, you can think of it as being similar, causes large resistance by forcing electrons to do much work when passing through them, just like water has to work really hard to get through that pipe. Buildup of a lot of pressure. 7, conductance, the measure of how easily current flows through a material. So of course you can see conductance and resistance are opposite. Resistor cause electrons great difficulty in getting through it, whereas conductance looks at how easily it can go through. So as you raise the resistance, you lower the conductance, and vice versa. If you raise the conductance, you lower the resistors. Okay, Charles Ohm was a physicist who experimented with some of this stuff, and he came up with what was referred to as Ohm's law. voltage is directly related to I. The amount of electric current is directly related to the potential difference producing the surface. And if you were to do an experiment, alter currents, measure voltages, etc., you would get a straight line graph like that. So very similar to in math class, we have y and x. We would say y is directly related to x when you have a straight line like that. To change it to an equation, it's y equals some constant times x. And of course in math class, that constant is the slope of that line. So y equals mx, and then plus b if it's not going through 0, 0. Well, similarly here, with voltage and current, voltage is directly related to I. To change it to an equation, we introduce a constant, V is equal to K times I. And that K is the slope of this graph, and that is actually resistance. So in terms of Ohm's law, this is what he found. V is equal to, now quite often it's just rearranged here, V is equal to I times R. So the slope of a VI graph is resistance. So if we look at that equation, V is potential difference, which is measured in volts, current measured in amps or A, and resistance is ohms, or the symbol for that is omega, the Greek symbol omega. Looks like almost like legs with kind of a curved leg appearance there. So there's two units that could be used for resistance. If we solve this for R, it's V divided by I. So that's volts per amp, of course, or ohms for resistance. So two different expressions there. Okay, we'll look at a few questions involving that, and then you'll be ready to do your first quiz. Portable radio is connected to a 9-volt battery, draws a current of 25 milliamps. What's the resistance? So to use this equation, current has to be in amps, so we have to use this little conversion here. So earlier we looked at 1 amp is 1,000 milliamps. So in this case, to cancel out milliamps, we have to have milliamps on the bottom. So divide by 1,000, and we get 0.025 A. So V equals I times R. Rearranging this for R, V over A will give us R. 9 volts divided by 0.025 amps, that gives us 360 volts per amp, or of course we can represent that as 360 ohms. Okay, I'll have you try the next few questions. Maybe pause the video, see how you make out, set up the variables first of all, then use the equation, rearrange to what you need to have it to be at in order to solve for the unknown variable. Okay, if you had a chance to do that, do the work. Electric clothes dryer is connected to a 230 volt source of electric potential, has a resistance of 9.2 ohms. What's the current? So the information that we know is that. Now with ohms here, it may be beneficial to change it to the units of volts per amp. That way we'll be able to cancel the right units, etc. So V is equal to IA times R. Solving for I, we need to divide by R. So we have 230 volts divided by 9.2 volts per amp. So what happens is that the volts cancel, the A gets flipped up to the top, 25 amps. Next question. A large tube in an old television set has a resistance of 5,000, or actually that's 50,000 ohms, and draws 160 milliamp of current. What's the potential difference? So we're looking for V, we know I, and we know R. The only thing is, of course, I guess I did this earlier, changing milliamps to amps as earlier here, to divide by 1,000, 0.16 amps. So simply multiply those two numbers. Again, change ohms to volts per amp. That way the units will work out nicely here. Amps and amps cancel, and I'm left with 8,000 volts. I have 2 sig figs and 2 sig figs, so putting a line over that 0 will indicate that I have 2 sig figs. Or of course we could put it in scientific notation, 8.0 times 10 to the 3 volts. The last few here. An electric toaster has a resistance of 12 amps. What current does it draw when it's hooked up to a 120 volt supply? So we know V, we know R, we're looking for A, similar to the previous one. And of course ohms is equivalent to volts per amp. so we get 10 amps. A little bar over there because I have 2 sig figs, or we could write it in scientific notation, 1.0 times 10 to the 1 amps. E, potential difference required to move a current of 8.0 amps, having a resistance of 64 ohms. And of course 64 ohms is volts per amps again, so as you can see here, amps cancel, and I get 512 volts. Technically there are only 2 sig figs here. 1, 2, this is a 2, so this stays as a 1, so that should be rounded off to be 510 volts. Lastly, an iron is designed to use 120 volts at 5 amps. It's connected to a source that's 240 volts. Calculate the current the iron will draw at the higher potential and state what will happen to the iron. Okay, so if we have that, V is equal to IR, we're solving for R, V divided by I. So it's designed to be doing this. So it is a 24 ohm resistor. So we need to do that first, figure out what kind of resistor it is. Then from there, using that 24 ohms, figure out the current that it's drawing out now from a 240 volt supply, and you can see that's 10 amps. Double the current that it's supposed to have. So the wires may get too hot and they may in fact melt. Okay, so there we go. That's the end of the first video. You should be able to do the first quiz, and the second video will look at the rest of the material here dealing with resistance and resistivity.